Good day everyone, today we're going to learn how to create a decision tree in Python using VS Code. The first step is to install the required libraries, which are the scikit-learn and matplotlib. We can do this by opening the terminal in Visual Studio Code and running the following commands. But if you are a Mac user like me, write pip3 instead of pip. Scikit-learn is a powerful Python library for machine learning. It provides simple and efficient tools for data analysis and modeling, including classification, regression, clustering, and dimensionality reduction. In our code, we use decision tree classifier from sklearn.tree module to create a decision tree model for classification tasks, while matplotlib is a plotting library for Python that produces publication quality figures in a variety of formats and interactive environments. In our code, we use matplotlib.pyplot to visualize our decision tree model. In some cases, Python 3 -m might need to be added before these commands. Python 3 is the Python interpreter which is used to execute Python scripts. In this case, it is used to run the pip command. -m is the option used to run a module as a script. In this case, it is used to run the pip module as a script. This line imports the specific tools we need for the scikit-learn library, which is a popular library for machine learning in Python. We are importing the decision tree classifier class for creating our decision tree model and accuracy_score for evaluating its performance. We also import matplotlib.pyplot to help visualize our decision tree. The decision tree classifier is a class from scikit-learn used to create a decision tree model for classification tasks. Decision trees are a popular and intuitive type of machine learning model that can be used for both classification and regression tasks. Accuracy_score is a function from scikit-learn used to create the accuracy of a classification model. It compares the predicted labels with the true labels and returns the accuracy score. We use PLT as an alias for matplotlib.pyplot, which is a module within matplotlib used to create plots and visualizations.
Here we define our dataset. X represents the features which are the inputs to our model, or in simpler terms, the independent variables used to determine patterns and make predictions. In this list, each pair of numbers represents an employee. The left-hand value represents the number of hours they have worked, and the right-hand value represents the units of output they have produced. So for example, we have here first on the list 8,253. This means that employee 1 has worked 8 hours and produced 253 units of output. Now on the other hand, Y represents the dependent variables that are being predicted. In this case, we want to predict whether or not an employee is productive. So in this list, each number corresponds to an employee in the same order as before. A value of 0 means that the employee is unproductive, and a value of 1 means that the employee is productive. So for example, employee 1, who has worked 8 hours and produced 253 units of output, is considered by the company to be productive. With this, the model is trained to analyze the relationship between work hours and output produced to predict whether or not an employee is productive. Now we create a decision tree classifier model, which is a tool that learns patterns from data to make predictions or decisions. And then by using the fit method, we then train the model with our x and y values. What we want is to teach the computer to understand why some employees are productive and why others are unproductive, based on how long they work and how much units of output they produce. This is so that it can predict if a new employee will be productive or unproductive.
Predict whether the employees are productive or unproductive. Let's say a new employee comes along who worked for 8 hours and produced 295 outputs. Then, we use our trained model CLF to predict whether the employee is productive or unproductive. Print the prediction. Finally, based on the prediction, we print a message indicating whether the employee is productive or unproductive. If it thinks the employee is productive, which is represented by 1, then it will print the employee is productive. Otherwise, it will print the employee is unproductive.
The last part is optional as it visualizes the decision tree model we created. It helps us understand how the model makes its decisions based on the features. We use plot_tree function to generate the visualization. After running the file, a diagram of the decision tree will appear. And here in the terminal, you can also see the print, "The employee is productive." There are 3 types of nodes in a decision tree plot: the root node, the decision node, and the leaf node. The decision nodes indicate the direction of the nodes. Decisions are solely based on the features including the Gini, sample, and values. The Gini is considered to be the probability of misclassification. It is taken into consideration that the Gini must have a low probability. Samples are considered sample size, and values indicate the total number of productive employees on the left bracket side and the total number of unproductive employees on the right bracket side. Which value has the greater value will acquire the name of the classification. The decision tree is classified into 2 categories, namely productive and unproductive, based on their work hours and outputs produced. If the work hours of an employee is less than or equal to 8, then it satisfies the productive classification on the left side. If it does not satisfy the first node, then it is classified as unproductive. The samples indicate the number of lists that satisfy the condition. For example, work hours is less than or equal to 8.5. There are 2 pairs of values that have work hours greater than 8.5, and 4 pairs of values that have work hours less than or equal to 8.5. If it's less than or equal to 8.5 hours, it will ask another question, which is outputs produced. Then, if the outputs produced is less than or equal to 205, then the employee is productive. Otherwise, the employee is not productive.